Idealizations in mechanics. Now in engineering system, if we study it in thoroughly, that consists of various parts or number of bodies. If we take a small example, that is of our planetary system. So in our planetary system, if we observe the sun at the center and there are number of planets available in the different, we can say, the circular path that will be rotated with respect to the sun. But here we have a two type of study that we can done. So one study that is related to rotational motion. So we consider here a sun and a earth. So to study the motion of a planet, so take earth is our planet and we want to study that earth, the motion of a planet that around the sun. So the planet, or we can say the earth, that is idealized as a particle with whole mass that is lumped at a single point. However, to study the planetary motion about their own axis, now if we consider earth as a single body, so now this is our earth and that is our purpose of study, or we can say the body that we want to study. So there are two cases, in this case number 1 and in this case number 2. So in case number 1, the earth is rotated around the sun and here the particles of the earth that is rotated around the centroid of this earth. So here the study of the planet around the sun that we can do using the, or we can say the considering the single particle, earth has a single particle, and here we can study the earth as a rigid body. Always the mathematical description of a real engineering problem can become very complex. So it is required to follow some idealization, or we can say the models or the assumptions that we have to use, which are helpful in making practical problems more comprehensible and simple, and that resulting into a fairly accurate solution to a complex problems. So let us take one by one. So first one, we take particle. This is a idealization. Now generally we define a body as a particle. So it is an idealized body which may have a negligible mass. So whatever the body we can take, but we consider that as a particle, but it has very negligible mass. So for the study, consideration of the mass, that is not that much important. If we take size and shape, size and shape of that body, now that is also not that much important to the study, so that is also ignored. So this is ignored. Now second thing, this particle we just consider as a point mass, whatever the body we have, whatever the mass it has, whatever the size and the shape, but that is considered as a simple point mass. In other words, it is defined as an idealized body whose size does not affect its response to the factors affecting on it. So I said that there will be a mass is there, shape is there, but for the study purpose, if we consider that as a simple point or a mass point, so there will be a no effect generated on it in its response. So if we take as an example, if we take that is an example, a vehicles, let us say it is like a cars, trucks, trains, though they are not a particle, it has some body parts, tires, engine, some part of steel, wooden, different materials, but they are generally treated as a particles if we are interested in finding out its velocity or its acceleration. So if we consider that in different manner with that shape, size, but for the study of that velocity and acceleration, that is not that much important. So for the study of those type of bodies, the linear motion takes place as a single unit without rotation about the mass enters. So it is very much appreciable idealization in the mechanics, that is the body is considered or body is idealized as a particle. Now if we go further and take a second idealization, that is a rigid body. Now whatever body we take for the study, so it can be considered as a rigid when the dimensions of the body that will not change if we apply any type of action or the force, so the dimension will not change. That is one factor. Second thing is that it is also generally assumed, or we can say in other words, that distance between particles does not change. So after the application of forces or action, when we apply on a body, so there will be a no distortion available, no any change in the dimension, shape, size, there will be a no distance decrement or increment in the particles. So that type of body we considered as a rigid body. But this idealization, if we say that in reality no body is perfectly a rigid body, so that we can quote here, that is no body is perfectly rigid. Now the meaning of that is, if you take any body that is made up with any material and apply action, or we can say the apply a force, maybe with the small amount or a higher amount, so there will be definitely a deformation available But for mechanics, or we can say the study of mechanics, we can assume that or number of theories are derived, and that can also required to assume a body as a rigid body. So we can prove many things by considering it. So this is also important idealization. So in example of that, if we take, so if we take an example of our buses. So buses has a many type of different elements available, many type of different material used. It is definitely a body that can be destroyed by any application of the force, but it can considered as a rigid body when, if the interest is to know the angular velocity of the vehicle. So with respect to this type of interest, there will be a no difference occur if we consider as a rigid body. So this is uh, another important idealization for the study of mechanics. Now if we go further, we take a third one, and this is I think exactly opposite to the rigid body idealization. So this is deformable bodies. So as we discuss here, rigid body, there will be a no dimension change, no change in the distance between the particles after the application of force. But here in deformable body, the dimension of the body or the element that will be changed. So the dimension of body will change. Same way, the distance between the particle will be changed. So this type of body, so when we apply a force on a body, and that body will deform under the application of load, so that type of body is generally known as deformable bodies. This type of deformable body, if we take, so the such deformations we can take in either a linear form or a angular form. Maybe it is in a temporary form, or maybe that is in a permanent form. So generally all bodies are deformable to smaller or a greater extent, and that is depend upon its rigidity and the magnitude of application of the forces. So generally, if we take a rigid body and a deformable body, so in mechanics we have a number of different part for the study. So in pure engineering mechanics, we consider every body as a rigid body, and in a part where we study the capacity of the materials, so in that we consider every body as a deformable bodies. Further we go, so we have another idealization, that is nothing but continuum. Continuum is nothing but it is generally known as the mass of body that is well dispersed in across the volume. So we can say the mass is, or the mass of body that is dispersed across its volume in a proper way, or we can say the evenly, or we can say the homogeneously, that is generally known as the continuum. So if a body is considered to be made up of number of particles which are interconnected to form a particle shape, and it can be treated as a continuum if it is the very well dispersion of particles throughout the volume of the body, and the idealization of a body in other way we take as a continuum that ignores the presence of the void. So we can say the voids are not allowed. So without void, that means the completely a solid body that we assume, and this type of body we take, or we generally observe a solid part to be present everywhere in the body, so that we generally known as a continuum. Next one, that is uh, point force, point that we generally considered as a concentrated. So it is known as a point force. So it is a type of application of the force. So it is an idealized force. We assume that the force is to be at a particular point. So if we take a body that is considered as a continuum, and that force, whatever the force is acting, so generally that is acting on a whole body or the part of the body. But here in this idealization, if we mark arrow or say the point force, so this is a point where actually the force is acting. So we generally idealize that in reality there will be a force acting on a whole body, but this is a point where we consider the force is acting, and that is also very much important in our study, so we can define a force in a particular manner with its magnitude, direction. And this is a third point that is very much important, so that is the point force. So if we considered a small floor, example of a floor, and any person, if we take and he's standing on the floor, and that person applying some force, so whatever the weight of that person available, that is transferred to this floor. So we considered that we are not going to consider the what type of force is available here and how there will be transfer from the different part of the body, but generally we assume that or idealize that there is a one point and the force would be transferred through that point only. So that is our concentrated force assumption. So now in idealization of mechanics we considered two type of body. One is the body that rotate about a different point. So in this we considered body itself a particle, and secondly we take body particles rotate about a center. So in that we considered body as a rigid body. So in this context we have to take different idealizations. That is a particle, so that is nothing but we consider the body as a single point mass. In rigid body we consider the body that will not deform in any applied action or under the any applied action. In deformable body we see that there will be a deformation, either a temporary or the permanent in the body after the application of the force. And the continuum is nothing but a mass of the body that is dispersed across the volume, and that particle will make a particular shape, and there will be a no presence of any type of void. And further we have a point force, that is a point where the force we consider that will applicable on it. So point force, or the point concentrated force that we consider in mechanics, that is the force is applicable at that particular point, and based on that we do the analysis. So this is all about idealization made in the mechanics.